Okay, hi guys, I'm your thermodynamics tutor over here, Mr. Lau. So today I'm going to go through assignment 1 or tutorial 1. Okay, so without further ado, let's begin. Okay, so for question 1, okay, we have a rigid vessel having a volume of 2.5 meter cube. Okay, so the volume of the vessel will be 2.5 meter cube. Okay, and it's holding 8 kg of air. So the mass of air is 8 kg. Alright, and under high pressure, if 20% of the air leaks out, determine the final mass of the air. So A, determine the final mass of the air. So the final mass, in this case, since 20% leaked out, so I should have 80% left. So 80% of 8 kg give you 6.4 kg. Alright. Okay, next for B. Determine the final density of the air in the vessel. So this one, okay, so density is equals to mass divided by volume. So the mass is 6.4, the volume is 2.5, and this should give us our 2.56 kg per meter cube. Alright, that's it for question 1. Okay, next for question 2. Okay, we have a cylindrical storage tank of diameter 2.5 meter. So let's again write down the values given to us as a habit. Diameter is 2.5 meters, height 3.6 meter, completely filled with cooking oil. The specific volume of the cooking oil, okay, is 0.0012 meter cube per kg. Alright, so these are the information given. Part A, determine the density of the cooking oil. Okay, so to determine the density, again we can use the formula. Density of the cooking oil is equals to 1 over specific volume of the cooking oil. Alright, so this is simply 1 over 0.0012, and this will give us our 833.3 kg per meter cube. Okay, B, determine the volume of the cooking oil in the storage tank. So in this case, the volume is only dependent on the container itself. So the container is cylindrical in shape. So the volume formula for the cylinder is pi r square h. Okay. However, in this case, since we are given the diameter, so we got to convert the r into d over 2 square. Okay. So from here we can plug in. So pi times 2.5 divided by 2 square times 3.6. Okay, so this will give us our 17.67 meter cube. Alright, and lastly for C, we are asked to determine the mass of oil. Okay, so in this case the mass of oil can be found using the density of oil multiplied by the volume of the container. Okay, alternatively, another formula to use the volume of the container divided by the specific volume of the oil. So either way is the same, so I'm going to use the first one, okay, which is going to be 833.3 multiplied by 17.67, okay, and this will give me my 14724.4 kg. Alright, that's it for question number 2. Okay, let's move on to question number 3. Question number 3. Okay, again we have a cylindrical storage tank of diameter 2.8 meters. Okay, so diameter of the cylindrical storage tank is 2.8 meters. And the height is 10 meters. Okay, so it's completely filled with a certain fluid. The mass of the fluid in the tank is 54,000. So mass of whatever fluid it is 54. 1000 kg. Okay, and the density of the water is 1000 kg per meter cube. Okay, so density of the water is 1000 kg per meter cube. Okay, determine the volume, density, and the specific gravity of the fluid in the storage tank. Okay, so let's determine in this case, the volume first. Okay, so for the volume, again, it will only dependent on the container. So cylindrical, so pi r square h, pi d over 2 square h. Plug in the numbers. Okay, d in this case is 2.8 over 2 square times 10. Alright, so this will be 61.58 meter cube. Okay, so after we determine the density of the container, we can go ahead and find out after finding the volume of the container, we can go ahead and find out the density of the fluid. Okay, so density of fluid, we'll use mass divided by volume. Right, so 54,000 divided by 61.58, and this will give us our 876.9 kg per meter cube. And lastly, for the specific gravity of the fluid, the definition for specific gravity is density of the fluid divided by density of water. So essentially it's just dividing 876.9 divided by 1000. Okay, so this will give us our 0.8769. Alright, so that's it for question number 3. Okay, next, question 4. Okay, we have a weather research instrument suspended below a helium-filled balloon with which is a sphere of 1.725 meter in diameter. So this sphere has diameter of 1.725 meters. Okay, the specific volume of helium, okay, is given to be 5.62 meter cube per kg. Okay, determine the volume and the mass of helium in the balloon. Okay, so again, to determine the volume depends only on the shape. In this case, it's a volume of a sphere. Formula is given to us, 4 over 3 pi r cube. Okay, so 4 over 3 pi times d over 2 cube. Applying the numbers, 4 over 3 pi 1.725 divided by 2 cube. Right, and this value here will be 2.688 meter cube. Okay, so this is the volume of the spherical balloon. Okay, next we can determine the mass of the helium balloon, or the mass of the helium. Okay, so in this case it will simply be density times volume. Okay, so density is 5.62 multiplied by volume, which is 2.688. So this will be 0.4783 kg. Okay. Oh, a slight mistake over here. Okay, because this density, right? Okay, density is not 5.62. 5.62 is our specific volume. So density should be 1 over 5.62. Okay, why? Because density is defined by 1 over specific volume. Alright, so just a minor correction. Okay, so that's it for question number 4. Okay, finally we move on to the last question. Okay, question number 5. Okay, so we have an empty bottle with mass of 1.2 kg. Okay, so the mass of empty bottle is 1.2 2 kg. Okay, so the mass of MT plus water is 1.7 kg. Okay, so straight away from here we can already know that the mass of water is how much? 0.5 lah. Oh, simple mathematics. 0.5 kg. Okay, so we are also given that if the bottle is filled with another fluid, the mass of the whole thing, which is the MT plus the fluid, is going to be 1.5 kg. Okay, so this is equivalent to telling us that the mass of fluid is 0.3 lah. Alright, so just a quick inference from the data given by the question. Okay, it's also given that the density of the water is 1000 standard. Okay, so A, determine the volume of the bottle in this case. Okay, so we can determine the volume of the bottle, okay, by using the mass of the water and the density of the water. Okay, because the water is taking the shape of the bottle itself. Okay, so the volume of water is equivalent to the volume of the bottle itself. Okay, so the volume of the bottle is equivalent to the volume of the water. Okay, and to get the volume of the water, we'll use the mass of the water divided by the density of the water. Okay, so this is 0.5 divided by 1000, which will then give us a 0.0005. Okay, very small bottle. Okay, B, to find the density of the fluid. Okay, so to find the density of the fluid, okay, we will use mass divided by volume. Okay, mass of the fluid and the volume of the fluid also. Okay, mass of the fluid in this case we already know is 0.3 lah. How about the volume of the fluid? So again, because the fluid is taking the shape of the bottle, so as I mentioned, the volume only depends on the container, okay, which is the bottle in this case. Therefore, the volume is 0.0005 as calculated from part A above. Okay, so this will give us 600. Alright, and then C. Okay, we are supposed to find out the specific gravity of the fluid. So again, follow the formula, which is the density of the fluid divided by the density of water at 4 degrees Celsius. So it's 600 divided by 1000, and this will give us our 0.6. Alright, okay, so that's it for tutorial 1. So welcome to the class of thermodynamics. Hope you can enjoy the course itself and find it useful in your future applications. Thank you. Mr. Lau signing off.